Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Question 7 from the 2020 Leaving Cert higher level paper was in area and volume. So company makes biodegradable paper cups in the shape of a right circular cone. Each cup has a radius of 3.3 centimeters and a slant height of 9 centimeters as shown. Show that the vertical height of the cup is 8.37 centimeters, correct to 2 decimal places. Okay, so show that it's 8.37. If we go back to your log tables, which has area and volume at the start, I'm looking at a cone. I know that's in the log tables. So you can see the slant height L, radius, and you can see the vertical height H. Okay, so the easiest way to see it is to draw the vertical height in as such. So you end up with a right angled triangle. Let's see if I can draw that better. As such, inside your cone, okay, where that's 3.3, that's 9, and that's that vertical height H, okay, that I need to show is 8.37. So it's Pythagoras' theorem, which is c squared is equal to a squared plus b squared. C squared is always your hypotenuse, so 9 squared is equal to that h squared plus 3.3 squared. Or 9 squared minus 3.3 squared will give me h squared. So let me work that out. So 81 minus 3.3 squared equals 70.11. So h then, of course, is the square root of 70.11. So square root of answer on my calculator, and it's equal to 8.37 centimeters. Okay, part 2. Find the curved surface area of the cup, correct to 2 decimal places. Let's go back to our log tables. So in the following, A represents the curved surface area and V represents the volume of the solid in the question. Okay, so down to my cone, A is the curved surface area. So pi or L, just having a little look to see which height L is, and it's the slant height. So curved surface area is equal to pi or L. So it's equal to pi times my radius times my slant height. So let me put that into a calculator. So 3.3 by 9 by pi, and I'm getting 297 over 10 pi. I'm just having a look at my question. Do they want it in terms of pi or decimal places? And it's decimal places, so 93.3053 is what I'm getting for that. So 2 decimal places. I have to look at the third, and that's going to round that up to 93.31 centimeters, and its area, so squared. Right, so that was that part. Part 3, the diagram shows the net of a cup. So the net means you took this cone and basically you cut it open and you flattened it out, and that's the net of a cup. So in the cup, these two sides will be glued together. So that's the net of the cup. Find in degrees the size of the angle theta. Okay, so back to my log tables again. I know if I go back a page, I have an arc or a sector. When I look at this, I know that I could very much continue that circle. And that didn't work too well. But anyway, I could continue that and I will get a circle out of it. So this is actually the arc of a circle, and that's a sector. Okay, and that is here in the log tables. They have 2 formulas for this in the log tables as well. They have the length of the arc of the sector given by L, and they have the area of the sector itself. They take theta in radians or degrees. So we were asked for degrees. And that's the degrees formula. Okay, so how am I going to work out theta? And of course I could have taken, if I had known, 2 pi r theta over 360. Okay, my thinking though is I just worked out the cross section or the curved surface area of the cup, which is the area of the outside of that cup. Okay, so wouldn't that then have the same area as this shape here? Because all that is the cup flattened out. Okay, so the curved surface area from the last slide was 93.31 centimeters squared. So therefore, pi r squared theta over 360 for this shape must also equal 93.31. Okay, so let's sub in what we know. We know the radius of this particular shape is 9. So pi r squared theta over 360 is equal to 93.31. I want to multiply by 360. Okay. To get rid of it from the left, so that I get 9 squared is 81, so 81 pi by theta is equal to 93.31. 93.31 multiplied by 360. So I'm getting 33591.6. So let's divide across by 81, not 811. .81 pi and I'm getting theta, the angle, then to equal to 132.00, so 132 degrees. Okay. If I was to use the length of an arc, you can do that because you can work out the circumference of the top of that cup, and you can do it that way. Okay, part B. In order to avoid spillages, each cup is marked with a dotted line at F, which is 1 centimetre vertically below the top of the cup as shown. Find the volume of water in the cup when it is filled as far as the dotted line. Give your answer correct to 1 decimal place. Okay, so we want to fill the cup up with water to the dotted line. Right. Okay, find the volume of water. So let me go back to the log tables again. To my cone, volume is 1/3 pi r squared h. So volume of a cone is equal to 1/3 pi r squared h. So for this I need the radius and the height. Okay, so I have the height up to the dotted line. It's 7.37. I don't have the radius. Okay, so I need to find that radius first to find the volume of water in the cup. Right, so how do I get that? Well, it's not 3.3 because obviously a cone comes in as it goes down, so it's going to be less than 3.3. So we're going to, I suppose, use the fact that we have triangles in here. So let me draw that top triangle that we had in the first slide. Okay, and he was 3.3, and we worked out, we knew he was 9, and we worked out him to be 8.37. Okay, so that's the bigger one, if I can call it that. And then there's a smaller one here that's just got the blue water in it. So let's draw him. Okay, so he is my radius that I'm trying to find. He is 7.37, and I don't know the slant height here either. Okay, so I'm thinking similar triangles. This angle is common in both. Okay, so I know that angle is equal to that angle. I know this angle up here equals this angle here because both are right angles. So therefore, by default, because angles in a triangle add up to 180, I can say that the third angle is also equal. So I'm working with similar triangles here, and the theorem around similar angles tells me that sides are in proportion if the triangles are similar. Okay, so how do you do that? Well, you you take the sides that are similar to each other together. So in other words, my radius over the radius of the other triangle, and I did this triangle first, so he has to be on top all of the time, will be equal to 7.37, and the side that corresponds to that is 8.37. Okay, so what did I do there? I took corresponding sides together, so the radii correspond to each other, and the vertical heights correspond to each other. And he's there by division, let's bring him up. So radius is equal to 7.37 times 3.3 over 8.37. So by the time we work this out, we will have the radius of the smaller triangle, or the radius of the part of the cone that has the blue water in it in the diagram. So I am getting for that 2.905734. Okay, be careful at early stages of questions that you don't round too much, okay? Round at the end. So let's go back and find the volume of the cone. I have a third pi, my radius 2.905734. Even if you don't write down all the points, leave the radius in your calculator and use that in your calculation. So that's squared by, of course, the height, which is 7.37. Okay, so let's work that out. So that radius is in my calculator. I'm just going to hit squared. So I have that squared now in my calculator by pi by 1 over 3 by 7.37. And for that, I am getting my volume of my cone to be 65.164 centimeters cubed. It's 3D shape, 1 decimal place, 65.2 centimeters cubed. So that's the volume of the cone. C. Water flows into one of these cups through a cylindrical pipe of radius 0.8 centimeters at a flow rate of 2.5 centimeters per second. Find to the nearest second how long it will take to fill the cup to the line at F. Right, okay, let's think about this one for a second. So how long will it take to fill the cup up to the line at F? Okay, so we know what the volume of that water is. We just found it. So 65.2 centimeters cubed of water is what we need to fill. Okay, so we need to figure out, well, what speed is it coming out of this pipe at? So let's go back and see what the pipe is. It's a radius of 0.2. It's cylindrical. So, sorry, a radius of 0.8 centimeters at a flow rate of 2.5 centimeters per second. Okay, so per second. Okay, so let's find out the volume of water out of the pipe after 1 second has passed. Why did I pick a second? Because that was the unit of time that was given in the flow rate, so I kind of have to use that. Okay, so it's a cylindrical pipe. So volume of a cylinder is equal to pi r squared h. Okay, so it is equal to, where am I? Pi radius by your flow rate. So in other words, if you take that as a unit of measure of water as it's flowing out. Okay, so pi by 0.8 squared by 2.5. Okay, 8 over 5 pi is what I got for that. Right, so that's how much water I'm getting every second, and it's in centimetres and this is in centimetres, okay? So therefore, if I take the volume that I need and I divide it by, well, how much am I getting after 1 second? So 65.2 divided by the answer that was in that calculator, I am getting for this one 12.97 seconds is what it's going to take to fill that cup. So find to the nearest second, so 13 seconds. Okay, part D then. The company decides to change the position of the line F in order to limit the capacity of the cup to 60. How far vertically below the rim of the cup should the line F be drawn? Okay, so we need to figure out X. Give your answer in centimetres correct to 1 decimal place. Right, okay. Okay. So they don't want 65.2 centimetres of water in the cup. They want to limit it to 60. Okay, so we're going to come down more than the 1 centimetre in that case. Okay, so it's still going to be more or less working with it's going to be more or less what we've done in this case, apart from it's a little bit of working backwards. So between the two of these, okay, how did we work out the volume of water in the cone in the first place? Well, we used the volume of the cone, okay, and to do that we needed the radius and the height. Okay, so we still need the volume of that cone, which is equal to, let me just get that formula, 1/3 pi r squared h. And we need that to be 60 centimetres cubed for this question. Okay, so I need the radius of that new part and the height. Okay, so how did we get that in the last question? Well, we used similar triangles. So we're going to do that again here. Okay, so let me draw the big triangle. And I know that he's 3.3. I know he's 8.37, wasn't it? 8.37. Okay, and then let me draw my smaller triangle. Okay, so what do we know about him? Well, we know nothing. He's R. He's H. Okay. Yeah, we don't have either. We know the radius is dependent on how far down we've come, and of course we have to work out this height, so we don't know how far that line is going to come down. Okay, so let's proceed anyway. So the radius over 3.3 would be still equal to h over 8.37. Okay, so that bit doesn't change. Okay, I just don't have either. Okay, so let me think about this now for a second. I'm asked to find, so you have two choices here, okay? You can either write this in terms of or, so something like this, or I can write it in terms of h, so bring him up here. Okay, so there's my two choices based on this proportionate sides from similar triangles. So you write it in terms of or you write it in terms of h. So 8.37 or is equal to, I brought up this 3.3, I'm just making sure these are right, or h is equal to 8.37 or over 3.3. Okay, so that's my only two options for this question. And what you'll do is you'll sub in for or you'll sub in for h here, and you'll solve it. Okay, so the question is, do you care more about h, finding h in this question, or do you care more about finding or? Okay, so I would argue I would like to know what h is for this particular question, because once I have the height of this, I can subtract it from 8.37 and then I'll get this height x. If the question had asked me about the radius of the new, I suppose, the new dimensions of how much water is going to be in it, then I'd care more about r. Okay, so I care more about h. So in that case then, I'm going to leave h in the formula and solve for h, and in that case sub in for the r squareds. Okay, so I'm going to use this version here. So I hope my rationale there made sense. It's only because of what the question asked for. So third pi 3.3h over 8.37 squared times h is equal to 60. Okay, so a third pi. So again, using the rules of indices, and when you have something in a bracket, top and bottom to a power, you can multiply the top by that power and the bottom by that power separately. So that's what I'm using here. So let's go 3.3 squared. So 3.3 squared is a 10.89 h squared, and on the bottom I have 8.37 squared, and that's 70.0569. So no rounding yet, it's too early, by h is equal to 60. Okay, I might get rid of the third. Basically I have to get rid of everything on this side but the h, so it's whatever order you want to do that in. So third and third cancels. So I have pi times 10.89 h squared by 70.0569 by h being equal to 612, 180. Okay, let's divide across by pi. And let's multiply h and h squared together. So I have 10.89 h cubed now being equal to 180 over pi. Okay, so now I'm going to bring him up that side. I suppose to explain what I'm doing, I'm going to multiply by 70.0569 on both sides so that it cancels, so that I have 10.89 h cubed being equal to 180. I'm just going to tidy this up over pi, multiply by 70.0569. Okay, if it's okay with you, I'm just going to get rid of this from this side. It's in the recording anyway. So that I get 10.89 h cubed being equal to 4013.9646. Okay, divide both sides by 10.89. So h cubed is equal to, so I'm leaving that number in my calculator and dividing by 10.89. So I'm getting h cubed being equal to 368.5917. So h then would be equal to the third root of that. So again, leave the answer in my calculator. I'm doing shift the square root so that I can get 3 root. Answer equals 7.1699. 7.1699, and then back one decimal place, h is equal to 7.2 centimeters. Okay, so not done quite yet. Okay, what is x? So x then is equal to the original, which is 8.37, the original height, minus what we just found that the height we need it to be, so that there's only 60 centimeters cubed of liquid in that. So I have 8.37 minus answer, and I'm getting 1.2 centimeters for x. So if they come down 1.2 centimeters from the top of the cup, then the cup will hold exactly 60 centimeters cubed of liquid. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.